The most advanced space telescope ever built is the James Webb Space Telescope. In this video, we'll dive into how this groundbreaking telescope works, how it was meticulously designed and constructed across different parts of the world, and we'll take you on an emotional journey through its launch and voyage into the depths of space. When we gaze up at the night sky, our naked eyes can only capture so much. Moving away from the blinding lights of the city helps us see a little more. But to truly unlock the mysteries of the cosmos, we need something far more powerful: a telescope. Telescopes allow us to peer deeper and clearer into the vast expanse of the universe. Among the various types of telescopes, one of the most fascinating is the reflecting telescope, which uses mirrors to capture and direct light. Light enters the telescope, strikes a large curved mirror, and then bounces off to focus on a smaller secondary mirror, eventually reaching the eyepiece or a camera to record the images. Think of it like collecting rain. The bigger the bucket, the more rain you gather. Similarly, the larger the mirror, the more light it collects, allowing us to see distant objects with stunning clarity. A space telescope operates on the same principle, but on an unimaginably grander scale. Looking into the vastness of space is like peering back in time. Light travels incredibly fast, but it doesn't move instantaneously. For example, light from the sun takes about 8 minutes to reach Earth, covering a staggering 149 million kilometers. If something catastrophic were to happen to the sun, we wouldn't know for 8 minutes. The closest star to us, Proxima Centauri, is just over 4 light-years away, meaning we're seeing it as it was 4 years ago. Now imagine looking at stars thousands or even millions of light-years away. With a powerful enough telescope, we can observe galaxies billions of light-years distant, effectively turning the telescope into a time machine. This allows scientists to explore the universe as it once was, helping to answer profound questions about our existence, and even shedding light on how Earth formed. However, telescopes on the ground face a significant challenge: the Earth's atmosphere. As light passes through the atmosphere, it encounters shifting pockets of air that distort images and block certain types of light from reaching the surface. While placing telescopes on high mountains, known as observatories, can mitigate some of these issues, the ultimate solution is to place telescopes above the atmosphere. But launching anything into space is no small feat. It's incredibly challenging and expensive. Over the years, several space telescopes of varying sizes and purposes have been launched, but none are as iconic as the Hubble Space Telescope. Hubble was launched in April 1990 aboard the Space Shuttle Discovery. During its 5-day mission, the 5 NASA astronauts on board worked tirelessly to deploy this revolutionary telescope. Orbiting about 540 kilometers above Earth, Hubble captures light with its primary mirror, which then reflects onto a secondary mirror and redirects the light to scientific instruments at the back. These instruments capture breathtaking images and relay them back to Earth. Hubble's ability to see farther into the cosmos than ever before led to one of its most astonishing achievements: the Hubble Deep Field. In December 1995, scientists pointed Hubble at what appeared to be an empty patch of the night sky. After days of focusing on the same spot, they revealed a mind-blowing sight: a field teeming with distant galaxies. This discovery forever changed our understanding of the universe, proving that there is so much more out there than we ever imagined. Because Hubble orbits relatively close to Earth, astronauts were able to visit it for repairs and maintenance. Over the years, 5 servicing missions were conducted, with the last one in 2009. Each mission involved the space shuttle catching up to Hubble, allowing astronauts to open it up and replace or repair parts. However, with the retirement of the space shuttle in 2011, Hubble's maintenance options have been exhausted. As of December 2024, Hubble remains operational, but its future is uncertain. Despite its incredible achievements, Hubble has its limitations. It primarily observes visible light, which is only a small portion of the electromagnetic spectrum. Light exists in various wavelengths, from the large wavelengths of radio waves to the tiny wavelengths used in medical imaging. Our eyes can only perceive a fraction of this spectrum, interpreting different wavelengths as colors. The rest remains invisible without specialized instruments, like thermal vision goggles, which allow us to see infrared light, essentially the heat emitted by objects. Hubble, being an optical telescope, is mostly sensitive to visible light. But scientists have long known that focusing solely on this spectrum means missing a significant part of the cosmic picture. Enter the James Webb Space Telescope, often referred to as JWST, or simply Webb. This revolutionary telescope is designed to see beyond the visible spectrum, capturing infrared light to reveal hidden secrets of the universe. With its unprecedented capabilities, Webb promises to take us further into the cosmos than ever before, uncovering the mysteries of distant galaxies, the birth of stars, and perhaps even the origins of life itself. This is not just a telescope, it's a portal to the past, a key to understanding our place in the universe, and a testament to human ingenuity and the relentless pursuit of knowledge. Prepare to be amazed, because the James Webb Space Telescope is about to change everything we know about the cosmos. The universe is waiting, and its secrets are closer than ever to being revealed. Launched in December 2021, the James Webb Space Telescope is still relatively new, but it's already rewriting the rules of astronomy. Unlike its predecessor Hubble, Webb is an infrared telescope, capable of seeing beyond the visible light spectrum. This means it can peer into the hidden corners of the universe, revealing things that Hubble could never detect. Our understanding of the universe tells us it's expanding, with galaxies moving away from each other at incredible speeds. When observing galaxies that are far enough away, their light waves stretch due to their rapid movement, a phenomenon known as the Doppler effect. This stretching shifts what was once visible light into the infrared spectrum, a process called redshift. This light is no longer visible to telescopes like Hubble, which primarily observes visible light, with only limited capabilities in infrared and ultraviolet. Webb, however, was specifically designed to observe these distant, red-shifted objects, allowing us to look billions of years into the past and witness the universe as it once was. For example, while Hubble might only see the outer layers of stellar nebulas or gas clouds, Webb's infrared vision can pierce through these veils, revealing breathtaking views of their inner structures. But why is Webb positioned so far from Earth? Unlike Hubble, which orbits our planet, Webb is located about 1.5 million kilometers away, 4 times the distance to the Moon. This places it in the cold, dark void of space, near a Lagrange point. Lagrange points are unique positions in space where the gravitational forces of the Earth and Sun balance out, allowing a spacecraft to remain stable with minimal fuel consumption. Webb is positioned at Lagrange point 2, L2, a spot that keeps it far enough from the sun's light to avoid interference while still maintaining a relatively close connection to Earth. This strategic location is crucial for Webb's mission, as its instruments are incredibly sensitive to heat. Even its own heat could disrupt its ability to detect the faint infrared light from distant stars and galaxies. To ensure it remains cold and dark, Webb is equipped with a massive sun shield, roughly the size of a tennis court. This diamond-shaped shield consists of 5 layers, each as thin as a human hair, designed to block out sunlight and keep the telescope's instruments at the frigid temperatures required for optimal operation. Webb's design is unlike any telescope we've seen before. While Hubble has a long, tube-like structure to block out ambient light, Webb's unique configuration is tailored for its mission in deep space. The sun shield ensures that the sensitive instruments on one side remain perpetually in shadow, while the other side houses the spacecraft bus, which contains the electronics, communications systems, and propulsion. Above the sun shield, the telescope is divided into 2 main components: the Integrated Science Instrument Module, ISIM, and the Optical Telescope Element, OTE. The OTE features a primary mirror made up of 18 hexagonal segments, a design choice that allows the mirror to be built in sections and folded for launch. This ingenious design enables Webb to have a mirror significantly larger than Hubble's, capturing more light and providing unprecedented clarity. Light entering the telescope bounces off the primary mirror, reflects onto the secondary mirror, and then travels into the scientific instruments at the back. These instruments, each with a unique purpose, allow Webb to detect the oldest and most distant objects in the universe, study the formation of stars and planets, and even observe objects within our own solar system. The journey to bring Webb to life was anything but easy. Development began in the early 1990s, shortly before Hubble's launch. But progress was slow. Construction officially started in 2004, but the project faced numerous delays and was nearly cancelled in 2011. Despite these challenges, an international team of scientists and engineers persevered, working tirelessly to build and test the telescope's components. Webb is a collaborative effort, with contributions from NASA in the United States, the Canadian Space Agency, and the European Space Agency, which includes input from numerous countries. The hexagonal mirror segments, made of lightweight and durable beryllium, were constructed in various locations across the United States before being assembled in Boulder, Colorado. A thin layer of gold was applied to the mirrors to enhance their ability to reflect infrared light. The sun shield, built in Huntsville, Alabama, was designed to fold compactly for launch, while the ISIM and OTE were assembled at NASA's Goddard Space Flight Center in Greenbelt, Maryland. The meticulous assembly process involved a giant robotic arm, carefully placing each mirror segment, a task that took 3 months to complete. Protective covers were removed in a clean room environment to ensure the mirrors remained flawless, free from scratches or contaminants that could distort images. Once assembled, the telescope underwent rigorous testing. Packaged into a specialized shipping container called STTARS, it was flown to Houston, Texas, for cryogenic vacuum testing at NASA's Johnson Space Center. Inside the massive Chamber A, the largest high-vacuum chamber in the world, Webb endured 100 days of extreme cold and vacuum conditions to simulate the harsh environment of space. After passing these tests, the telescope was flown to Redondo Beach, California, for final assembly at Northrop Grumman. By August 2019, Webb was ready for its journey to space. The telescope was transported to the Guiana Space Center in French Guiana, where it was folded and depacked into a rocket for launch. The next time it would unfold would be in the vast expanse of space, marking the beginning of a new era in astronomy. With a projected lifespan of 10 years and hopes of extending it to 20, Webb is poised to revolutionize our understanding of the cosmos. Its ability to see the universe in infrared light will uncover secrets hidden for billions of years, from the formation of the first galaxies to the birth of stars and planets. This isn't just a telescope. It's a time machine, a window into the past, and a beacon of human ingenuity. The James Webb Space Telescope is more than a scientific instrument. It's a testament to what we can achieve when we dare to dream big and push the boundaries of what's possible. The universe's deepest mysteries are waiting, and Webb is ready to reveal them. Prepare to be amazed, because the cosmos will never look the same again. This time, transporting the James Webb Space Telescope required a custom-built shipping container, aptly named Super STTARS. The journey began with a slow and careful road trip, as the precious cargo was hauled by a massive truck. But this was just the beginning. Instead of taking to the skies, the telescope was loaded onto a cargo ship, embarking on a 16-day voyage from the coast of California through the Panama Canal and finally arriving in French Guiana. Every step of the way, the team ensured the telescope's safety, knowing that this mission was too important to risk even the smallest mistake. Once in French Guiana, the Ariane 5 rocket, owned by the European Space Agency, awaited its payload. This proven launch vehicle, with its two side boosters, main stage, upper stage, and payload fairing, was the perfect choice for such a delicate mission. Inside the final assembly building, the finishing touches were applied. The telescope was carefully lifted and installed at the top of the rocket, followed by the payload fairing. Then, the rocket was moved to the launch pad, where it stood ready for its historic journey. Launching into space is always a risky endeavor, but this mission was especially nerve-wracking. The telescope would endure violent shaking during liftoff and then face the harsh, cold vacuum of space. Years of meticulous testing and preparation had led to this moment. There was no room for error. On Christmas Day, 2021, the world watched as the Ariane 5 rocket roared to life, carrying the James Webb Space Telescope into the heavens. At 2 minutes and 21 seconds after liftoff, the solid rocket boosters, now out of fuel, detached and fell back to Earth. The main stage continued to propel the rocket upward until, at 3 minutes and 26 seconds, the payload fairing detached, revealing Webb to the vastness of space for the first time. 8 minutes and 48 seconds into the flight, the main stage separated and the upper stage ignited, burning for 16 minutes to set Webb on its path toward its final destination, Lagrange Point 2 L2. At 25 minutes, the upper stage shut down and the telescope separated, beginning its solo journey through the cosmos. It would take about a month to reach L2, with 2 weeks dedicated to the slow, precise unfolding of the telescope as it traveled through space. Every step of this process was closely monitored by teams of scientists at the Mission Operations Center in Baltimore, Maryland. The deployment of Webb was a series of heart-stopping milestones. First, the solar array unfolded, providing the telescope with the power it needed to operate. Next, the high-gain antenna deployed, ensuring clear communication with Earth. Within a day and a half, Webb had already traveled beyond the Moon's orbit. The unitized pallet structure, UPS, and the deployable tower assembly unfolded, increasing the distance between the sun shield and the sensitive instruments to help them cool down. The aft momentum flap deployed to stabilize the telescope in space. Then came the most delicate part, the deployment of the sun shield. This tennis court-sized structure, made of 5 ultra-thin layers, took several days to fully unfold. Once the sun shield was in place, the secondary mirror deployed, followed by the aft deployable instrument radiator to further regulate temperature. Finally, the primary mirror's 18 hexagonal segments unfolded. First the port side, then the starboard side. But the work wasn't done yet. The mirrors underwent a painstaking process called mirror phasing, where each segment was adjusted with microscopic precision until all 18 acted as one giant mirror. This process took weeks, but the result was nothing short of perfection. Unlike Hubble, which could be serviced by astronauts in low Earth orbit, Webb is too far away for any repair missions. Its design had to be flawless, with no room for error. Every component had to work perfectly the first time. And it did. On July 12, 2022, the first images from Webb were released, marking a monumental success. These breathtaking images revealed new details about the universe, uncovering discoveries no one had anticipated. As of December 2024, Webb has been operating successfully for nearly 3 years, delivering groundbreaking insights into the cosmos. This $10 billion project, 30 years in the making, represents the collective effort of thousands of scientists and engineers. It stands as a testament to human ingenuity and our unquenchable thirst for knowledge. What lies ahead for Webb? What other secrets of the universe will it uncover? From the origins of galaxies to the birth of stars and planets, Webb is poised to answer questions we haven't even thought to ask. This isn't just a telescope, it's a gateway to the unknown, a tool that will redefine our understanding of the cosmos and our place within it. The journey has only just begun, and the discoveries waiting to be made are beyond imagination. The universe is vast, mysterious, and full of wonders, and Webb is our guide to unlocking its deepest secrets. Prepare to be amazed, because the best is yet to come. If you've enjoyed this journey into the incredible story of the James Webb Space Telescope, there's so much more to explore. Dive into more space-related videos and uncover the mysteries of the universe. For those who want an exclusive behind-the-scenes look at how these videos are made, or even the chance to be part of the creative process, there's a special opportunity waiting